Chapter 4, Section 4, Little's MCAR test by Python. In this section, we will implement Little's MCAR test using Python. We will use the California housing dataset from scikit-learn. There are no missing values in this dataset. So, using this dataset, we will create data with missing values that occur randomly and data with missing values that do not occur randomly. First, let's import libraries such as NumPy and Pandas. And for implementing MCAR tests, we need to import MCAR test class. Next, let's import the California housing dataset from scikit-learn. After importing, merge the explanatory variables and target variables into a single data frame. Let's display the basic information of this dataset using info method. As we can see, there are no missing values in this dataset. So, let's create missing values in the column house age. First, randomly select 10% of all the rows and set the house age for those rows to a missing value. You can perform this operation with this code. After performing this operation, save the data frame as df_rand. In this data frame, the missing data for house age can be regarded as MCAR. Next, let's create a non-random missing data. Let's select 10% of the rows where the variable room is greater than the average and transform house age in those rows into missing data. We save this in a data frame called df_not_rand. In this dataset, the missing data for house age only occurs in observation where room is greater than the average. Therefore, the missing data for house age is not MCAR. Let's define a function to run Little's MCAR test and output the results. This function displays a message to indicate that there are no missing values in the data, and if there are missing values, it uses Little's MCAR test to test whether the missing data is completely random. In this hypothesis test, the null hypothesis is that data is MCAR. It outputs the p-value as a result, and displays a message to indicate whether the null hypothesis can be rejected or not. First, in the first line, let's define a function called Little MCAR test. Set data frame as an argument. It enables us to create a function that implements and outputs the results of MCAR tests by inputting a Pandas data frame. Next, let's use an if statement to set a condition that will display no missing values if there are no missing values. Data frame is null returns a data frame of the same size that indicates missing values as true and no missing values as false. By using sum twice, we will add up the number of all missing values, and if the sum is 0, we will display no missing values. Next, let's set up a class to run the MCAR test. Set the argument method to Little so that we can run Little's MCAR test. Let's name this as MT. Then, apply the Little MCAR test we have just defined to MT and set it so that we can obtain the p-value as a result of the MCAR test and store the p-value to the variable named p_value. Then, using print function, display the calculated p-value. Next, let's create this block to display a message based on the results of the hypothesis test. Let's set the significance level to 5%. So, let's set up this block so that if the p-value is 0.05 or more, the function displays a message, failed to reject a null hypothesis. Data is a likely MCAR. And if the p-value is less than 0.05, the function displays a message, reject a null hypothesis. Data is not MCAR. The defined function is applied to the original data frame, df, the data frame with random missing data, df round, and a data frame with non-random missing data, df not round. The output results show that there are no missing values in df. And for df round, the null hypothesis could not be rejected, which means that the missing data is MCAR. Finally, for df not round, the null hypothesis was rejected. In other words, the missing data is not MCAR, suggesting that it is MAR or MNAR. We can say that we could obtain expected and plausible results by this function. Thank you for watching. Please thumbs up and subscribe to my channel.